Okay, so let's discuss about this problem. The question is calculate the mass of aluminium deposited at cathode when 19300 coulomb of current is passed through molten electrolyte containing alumina, given the molar mass of aluminium is 27 gram per mole. Okay, so when alumina is converted into 2Al and 3O2. So this is the reaction. Basically, if you balance it, so it will be 2 4. Okay, so this is the balance equation. Now what the formula we need to use to calculate this is W is equal to EQ by F. Okay, so always remember the formula. This is the Faraday law of electrolysis, where E is the equivalent weight. Okay, so need to calculate the equivalent weight first. So equivalent weight is the atomic weight by the valency. Okay, so what is the valency of aluminum here? So a valency of aluminum is always 3. Remember that, always 3. So aluminum 3 plus, this is the 3, uh, and valency of oxygen is 2. Okay, so valency of aluminum is always 3. So atomic mass is given or molar mass is given, just 27 divided by 3, so it will be 9. So what does it mean? That when we uh, passed when we pass 1 Faraday of current, so at cathode 9 gram aluminium will be formed. So where uh, what do we need to calculate? The mass. So W is we need to write W is the mass deposited. E we got 9. Okay, and Q is given 19300. This is the Q. This is the Q. So using this formula you can calculate. And what is the F? F is 1 Faraday is equal to 96500. So 96500. Okay, so let's calculate this. Whenever we calculate this, we get the final answer. So 9 into 19300 divided by 19300 divided by 96500. So we get 1.8 gram. So answer will be 1.8 gram. Okay, so using this formula we can calculate. Again, there is another method which you can apply, that 1 Faraday, when 1 Faraday current is passed, so 9 gram aluminium is formed. Okay, in case of aluminium, 1 Faraday means 96500 coulomb. So when 96500 coulomb is passed, then 9 gram aluminium is formed, whereas the when 1930, then we need to calculate the amount. So 9 into 19300 divided by 96500, same is coming. So by this way also we can calculate. Remember that when 1 Faraday of current is passed at cathode or anode, one equivalent substance is formed, and one equivalent aluminium means 9 gram aluminium. So by simple way we can calculate. Again, in some cases question will be like that, calculate the amount of current. Calculate the amount of current. We need to then find the amount of current, that is Q, when suppose 5.4 gram aluminium is formed. Okay, so know that for 9 gram we need 9650 coulomb, right? For 9 gram aluminium we need 196,500. For 1 gram aluminium we need then 96500 divided by 9, then 5.4 gram. To deposit 5.4 gram we need then 5.4 into 96500 in coulomb, or if it is Faraday then you just write down Faraday instead of 96500, 5.4 Faraday divided by 9. Okay, so this is 9 into 6, 5.4, and that means 0.6. Okay, so need to we need 0.6 Faraday. This is simple way. Okay, so one question in your board exam, whatever the board is, that is in CBC or IC or any state board, one question regarding this, and basically aluminum, this aluminum is there in most cases. So and it will carry at least 2 to 3 marks. So I hope using this video you can calculate or you can solve this kind of problem. So this is the basic formula we are using, that is the Faraday's law of electrolysis. Any query, any doubt you have, you can give in, write down here. Okay. This is the Faraday law of electrolysis. You can follow these two laws. First one is the first law. The amount of substance deposited or liberated at cathode or anode is directly proportional to the quantity of electricity passed through the electrolyte. So the amount of product form is proportional to Q. Okay, the Q is the current and Q is equal to I into T, where I is the current ampere. Okay, and then T is the time in second. Current in ampere is I. You can see W is the amount of substance deposited, I is the current in ampere, and T is the time in second. Remember that the time in second. Okay, if minute or hour is there, so you need to convert into second. So Q is the current. Q is equal to IT, and Q unit of Q is coulomb. Okay. Then the second law says that when the same quantity of current, so if Q is fixed and two different electrolytes are there, so then the product form at the cathode or anode is proportional to the equivalent weight of the substance. Okay, and these are the two laws, and when we combine these two laws, we get this one: W is equal to IT by F. Okay, where F is the Faraday and 1 Faraday is 96500 coulomb. Okay, and Z, that is electrochemical equivalent, Z equal to E by F, and the equivalent weight, you can see the formula, equivalent weight is equal to atomic mass divided by valency. Okay, and valency of some common substances, some common metals are like aluminium is 3, charge is 3, zinc is 2 plus 2. Okay, copper, if copper is there, then basically it is plus 2. If silver is there, then it will be basically plus 1. So question, most of the question coming from these four metal. Okay, so you remember the charges and solve the previous year question, and if any doubt you have, you can write in the comment box. Okay.